My name is Glyn Darkin. I'm the UK Head of AI Engineering for Clearroute. This webinar, I'm going to be talking about scaling evaluation systems for agentic platforms from prototype to prod. So this presentation is really part two of kind of a series. Back in the summer, we did another presentation, which was practical lessons from building an agentic first developer platform. So if you're interested in this subject matter, please have a look at that. It's available on YouTube on the channel. So I'm going to sort of dive into it now. So when we talk about agentic platforms and agentic systems, we talk about evaluation as a testing strategy. Evals, evaluations, are typically it's the technology or the approach used for testing an LLM. From a software engineering perspective, the SWE benchmarks would be something that might be familiar to you. So when a large language model is released, it gets analyzed by many people and they get ranked on leaderboards. The software engineering benchmark is one where the models are analyzed for their ability to solve coding problems. And this is kind of really where the whole concept of evaluations sort of arose from. A SWE bench evaluation, an eval, is constituents of a couple of parts. So first there is the input, which for this evaluation is a GitHub issue. Then there is the solution, and this is the thing that the LLM model will do, which is solve that GitHub issue, so raise a PR. And then there's a verifiable result. And in this scenario, it's fixing a unit test. And so the SWE bench eval set contains 2,000 tasks, which are, a model is then used, packaged as in an agent, and then used to evaluate those issues. And this really kind of, goes to solving the problem of answering the question, can a language model resolve real-world GitHub issues? I've linked the white paper in this presentation that is the baseline for this evaluation set and this model and approach. And it's this inspiration that we need to take to evaluating our agentic systems. But an agentic system is more than just a model. And as we build our agentic systems and platforms, there are certain things and constraints that we need to consider and the types of trade-offs in the agentic system. So one of the things that's quite interesting is some of these results on the SWE bench leaderboard. So in this example, Sonnet 4.5 it solves 70% of the issues in that 2,000 plus set. And the total cost of execution of that is $279. So this is the cost of the tokens of actually running that set of evaluations, that eval set. And what's really interesting is if you start to compare it with different models, GPT-5 as an example can solve 60% of the issues, nearly 6% for $18. So it's a very different cost profile and a very different performance profile. And these are the types of problems that we need to uncover in our agentic systems. Are we building a system that we're prioritizing precision, so it's accuracy in solving the problem? Are we optimizing for costs? So these are the balance and trade-offs. And for us to be able to effectively test these different variables, we need to be able to have an evaluation suite around our agentic system to basically pick the right model, tune system prompts, and all of that kind of stuff. You can't really talk about evals without talking about vibes, and a recent interview with Boris Cheney from Claude Code fame. So he was recently interviewed on their YouTube channel, and he was asked what was the eval set for Claude Code. And his response was kind of interesting, because his response was they just run on vibes. I mean, it was a glib response, but it's quite an interesting, as you drill down into it, it's quite an interesting thought experiment. They have a very, very tight feedback loop with Claude Code. They make changes, they ship those changes out to all of the people that work at Anthropic. They are dog fooding the application, and they've got feedback straight away. So he talks about how quickly he can get responses and feedback from very quick changes. A very, very tight feedback loop. So his team members, the people that he's publishing to, are his eval sets. And so he's really testing live in that kind of context, which is an important part of your evaluation system. Most teams don't have this luxury. They have longer feedback cycles, external users will have different needs, and you need systematic evaluations for confidence. So really the question becomes that when do you sort of rely on the vibes, sort of your understanding of, yes, this works and I think it's working well, and when do you have a rigorous eval set and how do you do it? When we think of an agentic system, and this kind of harks back to the previous presentation we did, an agent is an orchestrated autonomous system that integrates both agents and workflows to pursue multiple goals, manage complex task execution, and adapt its behavior in response to dynamic contexts and feedback, enabling broad end-to-end problem solving with minimal human intervention. And there are starting to emerge different approaches to building your agents. Claude Code as an agent is obviously has a human in the loop, and it has a minimal set of tools, i.e. it uses Bash, but actually you can add MCP and things like that to it. But its problem space and the types of tasks it works on is very vast, okay? Whereas most of the enterprise solutions that we're going to be building are going to be quite tightly controlled in the type of task orientation that they're trying to resolve. If we drill down into that, our agent is composed of a few kind of components and then the platform. At the heart of it is the LLM. The LLM is the thing that is doing the orchestration, and it is the thing that, and the most important part here is it's using tools in a loop. So you'll send your request to the LLM, telling it the tools that you want to use, and in the response from that, you'll get the tools that it wants to execute. You'll execute the tools, you'll get the response from the tools, and you'll feed it back to the LLM. And in that loop, it will continue to resolve until it has completed the task at hand. We package that up in those parts into the agent, which is the system prompt, the tools that it's got access to, memory if it's persisting over time, so maybe some security controls around that. And we package that up into an environment. That could either be a command line, a Docker container if it's going to be headless, running in your CI pipeline, or it could be a chat interface. All of these are agents and have different dynamics. And then you run that on your platform, which is where you would expose things like your knowledge, which could be as part of your RAG system, your MCP mesh, your sandbox architecture, security, and telemetry. And these are the platform primitives that you're going to need to feed in to manage this as a part of your eval set. There's a white paper that I've linked into this, which is the React white paper, which talks about the dynamics of an agent and how to use them. So in my example, I have a simple agent. So this is the kind of prototype that we're starting off with. It's a simple agent. It is a command line application. It's a vibe-coded Rust application. It uses GPT-4 as its LLM, and its task is to produce commit messages from Git diffs, specifically conventional commit messages. This was started off as an experiment for me to kind of learn about how these tools work, but actually it's become quite a useful tool, and it's quite an interesting thought experiment. It truly is an agent because I've given the tools to the LLM and asked the tools to orchestrate, asked the LLM to orchestrate those tools. It has the freedom to call Git in multiple ways, not just the diff, but do other things and look at the Git logs and the history to compose the correct commit message. And a Git commit message costs less than a cent. They're pretty cheap, but as you could see, as you can imagine, like keeping an eye on cost and understanding the tokens was an important part of this experiment. This is available online. I've got it as publicly available in my GitHub. As you build this, you start to come up with a number of questions. These are recursive questions. Am I using the right model? ChatGPT versus Gemini versus Claude. Could I be using a cheaper model? How many times does the agent iterate? So just from the experiencing at the front end, I just see it goes off, it does it, and it comes back with a response. But how many times does it iterate? Sometimes it hallucinates, and why does it hallucinate? I have seen it do that a number of times. Could my agent do something rogue? It's got access to Git. Could it delete code? Could it do things that I don't want it to do? We talk about guardrails and how do we test for that? And then also, are the commit messages even good? Are they relevant? What's the quality of them? Which is kind of subjective. So with the pace of change in the industry, these questions don't go away. The more your system scales, the more agents you deploy, the greater the diversity of these questions. And cost is a reality. The more code we create, the more commits we make, the more dollars it's going to cost to run this system, right? So if it's a full platform, it can get very expensive. And the questions multiply. Every model release creates new questions. Is this model working? Is it better? Every agent that we add to the system, if we make it a multi-agent system, creates more complexity, and every feature needs more testing. So how do we do that systematic testing approach for something like this? Not just the vibes as Boris gets to do. So the typical software testing pyramid starts with a foundation of unit tests at the bottom that we can run quickly, get quick feedback from. Typically that would run in our CI environment. And then it would move on to our integration tests that would run tech potentially a bit slower, and we'd have a gated pipeline to go through these until we have our end-to-end tests. So how does this map to the evals, right? So an eval pyramid. So it looks exactly the same. It looks similar, but subtly different. So our unit tests, we want a set of unit tests like evals. So we want something that are quick, predictable, and cheap to run. We want to run those as part of our CI. And they're really just going to test the functionality. We then want the next set of evals are going to be more directional. So once we've built our system and we know that it's working and performing, how do we ensure that it doesn't drift? How do we ensure that the quality of the outputs don't change? And these are called directional evals, and these become more complex and can be much more expensive to run. And then there's testing in live. So most of us would be familiar with A/B testing, that the type of thing you would do on a website. How do you A/B test your agents? How do you deploy different features and manage those? And how maybe if you're going to have a human in the loop, how do you capture signal from human in the loop? If you start looking at eval frameworks out there, there are a number of frameworks. Deep eval is a common one, which is based on Python and is aligned to PyTest. PromptFoo is another one that comes out. Again, most of these frameworks are designed really around testing your system prompts against a model. Once we're into tool calling and multi-agent, it becomes very hard to use these tools. Also, if you're using something like Rust, like I am, there's very little tooling available to you. But that's not a problem, because actually you can vibe code these yourselves. You can vibe code sort of the testing frameworks and try to use what you're familiar with. I'm a software engineer. I'm not really a Jupyter Notebook person. I like to build my things with unit tests and the testing frameworks that I'm familiar with and the tools that I'm familiar with. So my basic set of evals. So I start off with, once I built this application and I was doing sort of some commits, I was capturing those in my log files, my Git diffs and the responses. So very quickly I built a set of log file data up. And what I've done is I've used that data set to create my golden data set. I pass those in. I have a unit test framework here inside Rust, and I've created a number of sample data sets which I feed into that. And when that unit test runs, I'm running it against my agent, against my system prompt. But when I get the results, what I'm testing for in the results are functionality. In this particular example, what I want is my commit messages to be conventional commits, which have a structure, so I can test that structure with a regular expression. So it's quick, it's pretty cheap, and what I can do is I can, make sure that the data set that I have looks at things like what happens if the diff is corrupt. It's a very small diff with not a lot of information, or it's a really large diff. How does the system behave? And I'm looking for just functional feedback. It's something that's quick, executes fast, and something I would put in my CI or my pre-commit hook. And this is what's called the golden data set. And again, it's running 50 test cases, runs quickly. I'd build my golden data set up, but I could get to see what my tokens are coming in. I can keep track and keep an eye on my costs. Building golden data sets can be difficult. But there are lots of options out there. So Hugging Face, which is one of the platforms for training data sets that people use for training machine learning models, has quite a diverse range of data sets. Interestingly, they have a large data set of Git commit messages and the responses that's been trawled from GitHub public repos. Here you can see this is me actually looking and investigating which of these Git commit messages adheres to the regular expression that I wanted to use for conventional commits. So I could use this as a data set, as my golden data set as well. So there are lots of options for building your golden data set. But a word of warning, that particular data set has over 1 million rows. If I took that and just loaded it into my test framework, it would cost over $1,000 to run a test against that. So again, you want to make sure that your golden data set is catered and specific, and you're testing against the boundaries of your application. So what happens for a corrupt disk, diff, small irrelevant changes, large complex changes. I want to make sure that that golden data set is testing the boundaries of my application and stress testing it. A lot of the time, though, we won't be able to identify those scenarios up front. It's only when people start using these systems in the wild that they get to find the scenarios that really break the system. And we'll come on to how do we capture those. So the next layer in our pyramid is the directional evaluation. So again, I'm using the same golden data set, using the same approach here. I take those Git diffs. I'm using my test framework around this again, but this time, rather than testing the results from the LLM, the regular expression, I'm using a concept called LLM as a judge. What I've done is I've created, I take the response from my agent, and I feed that back off to another LLM and say, can you please test this against the quality of the response against the objective that I'm trying to achieve. This is a common approach for testing the outputs of LLMs. And quite often in building agentic systems, we have LLMs fulfilling different personas as a part of an operation. So here I've got one generating the commits, and then I've got something reviewing the commits. Obviously, this is going to get a lot more expensive because for every single test scenario, where am I generating my messages, which cost me tokens, I'm then reviewing it again, which costs me tokens. It is also another part of my system that I have to tune. So, not only am I going to be looking at the data sets that I want to use and making sure that I'm testing all the different sort of aspects of my application, but I've also got to tune my system prompts for my LLM as a judge. There are other algorithms that you can use, and there are white papers. The DP-Val test framework has quite a lot of these built in. So you can tune and optimize the types of ways that you want to test that. Now, this type of test set is probably not something I'm going to be using in my CI every time I commit a change. This is the type of test set I'm going to be running if I'm doing a major change, a version bump, or maybe as a part of a weekly build, or if I'm doing contextual changes. So maybe I want to switch a model or do some tuning on the system prompt, then I'm going to be using this evaluation set. But as a part of the overall system, this might not be something that I'm going to be running all of the time because of the cost. Okay. And at the top of the pyramid, we have that testing and live concept. So really, to understand how your system works and how your LLMs are being called, what are the inputs, what are the outputs, you have to instrument your system. And this enables you to see and observe what's happening to your agentic system whilst it's running in that production environment. OpenTelemetry is a protocol that is a standard out there now for tracing your applications. And there are attempts to build sort of a meta convention on top of that called open inference. You can trace the full flow of your application using these standards. I've used a particular tool here called Phoenix, which is an open source tool. And it enables me to capture everything from when the session starts to the first agentic call, which is generate the commit message, the call out to the LLM, chat completion, the tools that the LLM then wants to call, and then the final result of that. And I can capture many other aspects in here. The system prompts that's being used, the model that was being used. We've got the latency and timings, even down to, you can see here, the actual cost as it calculates the tokens. So these are quite rich level of instrumentation. And what's interesting about these tools is once you start instrumenting and capturing this information, you can then start to determine what is a good, you can then start to flag things for good and bad results, right? So maybe you may decide that if particular calls take too long, or they go through too many iterations, these are the types of things that you could then flag as failures in your system, and you can capture them here. And then what you can do with that is you can capture that data and bring that information back into your evaluation set. These systems have the ability, many of these systems have the ability to convert these trace sort of data sources into data sets in the system. So you can capture them in the system, and then you can actually use them for prompt testing and prompt tuning. Again, with your agentic system, because you have all of the tool calls in the middle, that's a bit harder to do, but this is a really good way to capture that information, bring it back into your golden data set and use it for your other testing scenarios. Phoenix is an open source product. They have a SaaS cloud solution. If you're in the Python world with sort of Langsmith and LangChain, they have sort of LangChain and LangGraph, they have Langsmith. And there are a number of weights and biases and brain trust that come from sort of a heritage of the AI world with machine learning. So a number of these applications. And then we come down to really what Boris is doing with Claude Code. So testing with humans, right? So how do you discern that signal versus noise? How do you capture success and failure? So the first thing to do is design your agents so that you can expose a signal, a positive signal. The standard approach for building an agent and getting it shipped and getting feedback is to prototype, create your static set of evals as I did, ship it out to your users who start using it, start capturing that signal. So start capturing that telemetry in your telemetry system, understand your data. So going through, looking for the errors, looking for when things took too long or behaved in unexpected ways, and then adding those evals back into your system for testing. If you've got a human in the loop, which a lot of agents do have, and probably you may want to have in the first sort of phase of your application, you can design your system for explicit signal. So something like ChatGPT, where you get the thumbs up or thumbs down, that's explicit signal. That is where the user is saying, yes, this was a good outcome. But really in our agentic systems, we need to look for implicit signal. So where have actions taken place that would infer that it was a positive outcome? So in my agentic system, when a user approves a git commit message, that's a positive signal. If it's edited, it means it was probably a neutral signal. And if it's cancelled, it probably means it's a negative signal. And that means that I can then look at cancellations and cancelled scenarios and look at what was it in the message that potentially meant that it wasn't very good. If you're running your agents totally autonomously in a headless scenario, then you're going to have to come up with ideas around sort of LLM in the loop. So like we have LLM as a judge, how can we use LLM to derive positive signal from the application, from the agent? But it's important to design your agent to signal when something has been successful. And then finally, there's A/B testing. So shipping two parts or two features or two configurations in your application to different cohorts, and which one performs better? How do people use that better? But all of this is built around your telemetry system. So making sure you have that capability as a part of your platform that's encoding those signals. So to conclude on the calls to action, so we want to build out your observability primitives in your agentic platform. That's a core part of the sort of the platforms we have to build. Making sure that we're capturing all of the information correctly, we're storing that, and then we have the tooling available for the users to go in and do the information gathering and the exploratory analysis of those traces to make sure that they're getting the right information, and then we can rebuild that golden data set. So capturing that golden data set that you're going to use for your functional testing, focusing on the diversity of the use cases to make sure that you have a robust system. This used to be really quite hard, but again, with the ability to be able to, I use the word vibe code, but the ability to be able to use Gen AI, Claude Code for going through log files, parsing log files, all of that stuff is really, really easy to do and very, very quick to do. Build out your directional eval suite. This is something you could build out in something like Jupyter Notebook. Again, the tools I like are the sort of the unit testing tools. It's the way that I've been working. Using your LLM as a judge and treating that as a first-class tenant of your application, right? It's not just the testing framework that sits on the side. You have your agent and you have your your evaluation system. It's a first-class tenant of your application. Don't be afraid to create your own tooling. It's too early to couple yourself to third-party solutions. There's a huge amount of stuff coming tooling. Every day there's more tooling coming out. A lot of the open source tools are still trying to get you to tie you into their SaaS solutions. And I think it is too early to bite yourself into those systems. Things are evolving very, very quickly. So build the tools that you need, build what's relevant to your scenario. Don't be afraid to test in live, as you continue to evolve your systems, capturing that signal, using your telemetry to find those scenarios where your agent performed poorly. That sort of ability to really explore the system, explore the different routes is really important. Updating the golden data sets as every time you find those scenarios that don't work, those errors and failures. And then look for opportunities to use cheaper models that are more task focused. NVIDIA released a white paper recently where they believe that small language models are the future of agentic systems. I think as we build more of these platforms, the diversity of the tasks that they do will become larger, and having a diverse set of small models that are honed and tuned, evaluated and tested for very specific scenarios, and then coordinating all of those inside your platform is going to become more and more important. And again, as that complexity explodes, your telemetry system is going to be more and more important to be able to do that. So thank you. If you want to reach out to us, there are my contact details on the slide, and happy to take some questions now.
Yeah, thank you. Thank you very much. I've already had to mark to give this another rewatch for myself. I was like furiously taking notes as we as we went along. And I think, we're in a bit of an AI season in the terms of webinars that we've had. No surprises, I think, for everyone.
Yeah.
And it seems like a common problem with lots of the people in the organizations that are really at the cutting edge. We had a great webinar a few weeks ago from Google, and then one from someone at Broadcom. And the stuff that they're talking about, it's like the first time really that I have seen it in that detail. And this is another example. Obviously, I'm familiar with evaluation systems. There's like articles on it.
Yeah.
But at this level of depth, I think I'd be surprised if we're getting some people who are already so on the wavelength that they're going to ask really nitty-gritty questions.
That's great.
I think,
That's great.
which is, I think that's a big kudos to you guys. And I'm really happy with the types of stuff that's coming out.
The little tool that I've kind of built, these different scenarios, that's all up on my GitHub, so anyone can download that and have a play about with it. And I would encourage people to build these little agents and systems. There are only through building these little systems you start to think through the problems and the challenges, and then think how you industrialize those in a production environment. And then you start to kind of see the concerns and challenges that people will have. Are quite interesting.
I mean, that ties into the first question we've got here. It's actually a two-parter, but I'll start with the first one, and then we can spill into the next one. How do you decide when to build agent or agents using your own enterprise platform and environment versus building within a SaaS provider's platform using their tools?
Yeah, okay, good question. It's really an architectural and design decision, right? So there are too many right now. There are many competing things. So the thing that is going to drive that decision is probably going to be less technical and more environmental. So do you have an enterprise agreement for a platform, and that's the standard? Do you have a strategy that you want to decouple yourself because you don't want to be heavily tied to any individual cloud platform? We have one customer that we're working with that we're talking about agentic systems, and the CTO is saying, I don't want to be bound to my cloud platforms. We may switch those out. I don't want to, this is too early to be tightly coupled and be bound to any one cloud platform, because what happens if suddenly another cloud platform comes up with far better models or far better tooling, and then my cost of switching is high. I have another client. They're a bank. They're heavily on board with one of the cloud providers, which they aggressively want to use for the model management. They've gone through all of the processes around security, data governance, and all of that kind of stuff. So they're comfortable to use the models in that cloud environment. But from a compute perspective, they want to run it on premise. And so the dynamics here, these are not technical questions, these are architectural, and they're bound by sort of broader concerns within the enterprise. I definitely think the biggest challenge with a lot of these systems is going to be around security, as people are not familiar and the concerns around these, and plus security is becoming sort of an ever increasing challenge. So, you know, I think making sure that if you're pushing data through to the models, that it's going through a secure and compliant platform inside your enterprise is one of the key important things.
And I guess so that kind of tied into, I got quite a few questions on the YouTube, and then directly to me on that security front. And so maybe actually if you want to zoom in a little bit more on that idea of maintaining security through this, and how are you kind of ensuring that compliance and security aren't kind of forcing you to slow down too much or stopping you, but you're still kind of being compliant as you're building your agent or as you're working through the evaluation system?
Yeah, so I guess that there's two parts to that. So one is the movement of data through your agentic system through to the large language models and where they're being hosted, right? So one of our clients is they deal with very sensitive data, and they are implementing specifically around they're using OpenAI models, but on the Azure platform in specific regions, and they've gone through the whole data governance to clear that, right? So that is just one, controlling where the data goes and where the data flows. So they can't use any other model provider other than that one. Then the other aspect is controlling the execution of your model. So how your model interacts with its environment. So if that's running, like, which most of us are doing right now, have Claude Code on your laptop, you've actually given it full access rights to everything on your laptop. We're not running it in a Dockerized, sandboxed environment. But if you have concerns around the sensitivity and the operations that your model's doing, you want to control it in a sandboxed environment. And we talked about that more in the platform previous YouTube video around the sort of the platform primitives. And then the other aspect is actually how you design your agentic system. So the frameworks that you use and the principles that you use around that agent. So for example, do you take the principle that you want to have your model as close to the execution environment as possible? Again, if you take Claude Code as an example, it has access to Bash and can call any tool that is open on Bash, versus you create effectively a adapter layer over your tools, and you only expose the specific tools that you want your agent to execute. So your agent can only call the things that you give it permissions to call. And then there are sort of more broader concepts around, you know, separating writes and reads. It's like a classic database kind of securing architecture, you know, separating two agents that communicate, one that's doing all of the analysis, but the thing that's actually going to do any destructive changes is actually a different agent that has a different set of permissions, and they communicate. So you don't have one agent that can do everything all in one go. So you separate out the control, which means you can separate out the permissions environments as well. So there's quite a few different levers around that. And again, there are no best practices in this. A lot of this is emergent right now. You know, new frameworks are coming out that have different styles of building these agents. So yeah.
I think that is the tough thing that a lot of people struggle with, is this isn't really one of those things where you can just go and pull on, you know, a forum thread from 14 years ago that breaks down exactly your problem and what you should be doing.
Yeah.
We need to test, we need to play.
Yeah.
And, you know, I think
I do think, referring back though to sort of the white papers that are being released and the research, so the AI labs are releasing research, which is important. So for example, you know, the approach of using small language models and multiple of those as a part of your agentic system, that is going to have a very different design architecturally to where you would just have again, keep on going back to the Claude one, but it's the most well-known one. One model that can do many, many things, right? It's a very different design approach and architectural approach.
Well, that actually ties into the next question. How do you recommend testing across environments, individual agents and agents working together across a larger agentic flow?
So what the challenges with the larger agentic flows are you're going to have to build your own tooling around that. That's the reality of it. So having to build your own test harness that you can do that. So for example, another client that we're working with, they want to build an automation tool for doing some code migrations, and they're going to run this across a lot. Once it's built once, they want to execute this over a large estate, do lots of code migrations, and that's going to run headless. There's no human in the loop. So we're going to have to build, it's going to be a multi-agent solution. It's going to have to operate across a number of different paradigms to get to the eventual outcome. But our entire testing strategy for that is an end-to-end test harness. So how do we test the changes and validate those? And then how do we test the final outcome as well? Because it's code changes, it's a deterministic outcome. Does it compile correctly? Can we launch the application? Can we do those things? So they're more traditional testing approaches, but that's all going to be orchestrated via an LLM. And again, we're going to have to use LLM as a judge in testing scenarios. So we'll make the change, an LLM will make the change, and then we'll cross-validate to make sure that they've been done correctly with an LLM as well.
Nice. And for those who haven't seen yet, I've added the previous talk that was on building agentic platforms that was referenced just a moment ago. So that's in the chat if you want to watch that too. That was a fun one. So on to the next question. How would you use LLM as a judge if the agent uses SQL and RAG to give answers?
That's an interesting question. So I guess what we're testing here is the quality of the output that you've got. And I guess what you're trying to determine is whether the response was correct. If there's a deterministic answer in the sense of what you're trying to pull out is actual knowledge, then and you're testing, is it got the correct response? Probably that would have to be a different solution for that.
Makes sense. Thank you. And on to the next one. Can you explain more the concept of a golden data set?
So a golden data set for this scenario is a static data set that you use. It's a test data set that you will use and to feed into your system where you have a predictable and expected set of outcomes from that. So, typically your test data in a more traditional environment, you would have a test data set that you may be feeding in, which is, if it's an e-commerce site, for example, you may have a set of 5 products that you want to add to a basket, and you know what the price is, so you can test that the price has been calculated correctly. It's similar to that. So your golden data set is that static data set that you would use over time. But what we want to do with that data set is we want to evolve it so that it has scenarios in it that test the boundaries of the system. So in this particular example, I have about 50 records. So 50 git diffs, so 50 which I loop through, and that creates 50 individual tests of the scenario.
So as a follow-up to the previous point on LLM as a judge with SQL, so you evaluate LLM's thinking process. Does it make sense? No matter with golden answer or judge?
So this is testing the reasoning, presume is what the intent there is. So if you're exposing the reasoning, which you can do, so you can actually look through the reasoning process and the flow of what has been done by the LLM, then you can test and evaluate that. Both you can test the reasoning, is the reasoning correct? So you can use that statically and deterministically. So has that been something that you're expecting it to want to do? Or you can test that, with an LLM to see, has the reasoning been correct again?
And on to the next one. Do you have recommendations for when to decide human in the loop versus LLM as a judge?
Human in the loop is more around an architectural decision how you interact with your agent as opposed to LLM as a judge. I think the scenarios where I talked about where we're going to have to do the code migrations, effectively the system will not have a human validation step in it when we want to run it at scale. It will have to execute 100% by itself and validate at the end of that. because we're going to be running it over, I think, about 20,000 workloads. So you couldn't have a human, going through that. So we're going to have to run that at scale. And so we're going to use LLMs to evaluate the results of that as well. So has that been performant? Has it worked correctly? So we're going to both use just standard automation techniques, but also LLMs to determine the quality and the effectiveness of those every time it runs.
I guess to add on a cheeky point of my own, I think that question kind of speaks to a little bit of the challenge that I think a lot of people have with these kind of AI workflows that they're building, where you see lots of experimentation. We see this small scale experimentation, but no one is building experimentation for 20,000 workloads.
No.
And so but the thing that really delivers value will be
exactly
the AI workflow that works for
Yeah.
20,000 workloads.
And so in this scenario where we're doing this code refactoring, one person with Claude Code could do it very quickly and very easily, but you can't scale that, right?
Yeah.
So what we're going to have to do is break that down into lots of parts where we're using LLMs for very specific pieces, but they're much more, because they're smaller changes and more contained, we can control the inputs better, we can control the outputs better, and therefore we can get a much more predictable outcome and can execute that across a larger state with more predictably, right? And understand that we're going to get the right outcome that we want. And when it's failed as well, flag things, right? If it's got itself caught out. And quite often with these types of scenarios is if we're running it across 20,000 workloads and we get 500 failures, but flagging those up and marking those 500, that's still a massive impact and still a huge value gain by being the fact we've been able to automate it that way.
Yeah, absolutely. Absolutely. Thank you so much, Glenn, for joining. I think
thank you for the questions. There's some good
as a closing statement from myself, I'll take our last minute. I'm going to steal it from you. Sorry about that. For all of you here, many of you have watched some of our other webinars recently, and you're probably all familiar with a lot of the information coming out from these big reports recently, State of AI and Platform Engineering, DORA report, that famous MIT report around the 95% fail with platform engineering or are not seeing business value with their experimentation, and then the 5% who succeed. I'll really emphasize that what we're talking about here today in this webinar, that is the 5%. So if you've been watching and you were on your phone a little bit, or maybe you came in late, I would really recommend watching this one again and watching the previous talk we shared. This is, in my opinion, the cutting edge of the cutting edge, and it's really exciting to get to chat about it with you, Glenn, today. So make sure to connect with Glenn, and for all the 800 or so of you watching the recording, because you didn't want to come in here and join us, that's okay, I forgive you. But make sure to ask your questions and send them around. And huge thank you, Glenn. This was awesome.